Hi friends, welcome to today's video. So today we are going to discuss about structures and classes. So this is a very important topic and most of the time it is asked in an iOS interview. So throughout this video, first we'll discuss about what is the difference in structures and classes, and then why we should prefer a structure over the classes. And in the last section, we will going to see some of the interview questions, programming questions and coding questions that is generally asked in an interview. Okay, let's first try to see the differences in the structure and classes. So one of the common difference that we know is that structures are value type and classes are reference type. Now what does that mean? Let's see through an example. Okay, so what I have done, I have created a struct employee and then I'm creating object of that employee and assigning the name value as Nilesh. So now I'll create another copy of it. So I'll call it as employee 2 and then in this I'm going to assign employee 1. And then I'm going to change the value of employee one dot name to, let's say, app developer. Okay. Now what I'm going to do, I'm going to just print both the things. So employee one dot name and then print. So if you print right now, you will see that the value of employee one, which we are changing to app developer, that will get changed to app developer. But the value of employee two, that will remain as Nilesh. So why it is happening? So what actually happens when you create a value type object? So for each object, what the Apple is going to do behind the scene, that is going to create some address for you. Let's say that this address is 1234. In the real time, it can be anything. Okay. Now when you copy this object, again this is going to create a new address. It's not like that. It's not going to create a new address. So here it is going to create a new address, and here this address will have a different value 1235, let's say. Now this 1235 is the address of employee 2 and 1234 is the address of employee 1. Now in the case of value type, what is happening when you copy employee 1 to employee 2, this 1235 is basically going to hold the copy of employee 1. So in this case, if I talk about what is the value of name, it is having the name as Nilis. Okay. And here also, in this case, if I talk about what is the value of name, it is going to hold Nilesh only. Now what you are doing? You are changing the employee one dot name equals to app developer. That means you are changing this employee one, and this employee one is stored at the address 1234. That means now you are changing this address to app developer. So once you modify this address, see this 1235 address, this address has nothing to do with now 1234, because in the case of value type, you are actually copying the value. So whatever the value at that point you have, it's just copied. So next time if I'm changing this value, it doesn't matter. So that's the case that in the case of value type, if you modify the value, then the copied values are not changed. But the same thing, what happens if I run the same case for the classes? So let's say that now I just change this to class. And now if I run the same example, you will see that both prints app developer. So now classes are called reference type. Now how this works in the case of reference type? So the same thing in the reference type also, it will create address when you define an object. But when you copy this object, now this time this one, it will again create a new address 1235 or any specific address. This is just a reference. But this case, now it will not copy the value. In this case, what will this address is going to store? This address is going to store the address of 1234. Okay, so this 1235 address is not holding any value. Instead of that value, it is holding the address of employee one. So when you are changing the employee one value in 1234 address value to app developer, so what will happen? Once you try to access employee two also, it will try to access 1234, and then 1234 have app developer. So in this case, if you print both employee one dot name and employee two dot name, it's print the same value. So that is what it happens in case of reference type. So understood the difference between the value type and reference type in case of structure and classes and how they behave. So that's the basic and the most important difference between class and structure. Now we'll see some other differences as well. Okay, so I'm just going to delete all this thing. So in case of class, one thing what we extra get, we get a dinit method. Now this implementation of dinit method generally we don't use that much. So this dinit method gets called whenever the class is getting deallocated, and this you can use in your project to make sure that when you come out of any view controller or you want are deallocating any class, then this method is getting called or not. So if this method is getting called, that means there is no memory leak and your class is successfully getting deallocated. But see, if I change it back to the struct, then I don't see, the compiler will give me error that it doesn't recognize dinit, and this is supported only by the class. That's the second difference, that dinit are only there in the class, not in the structure. Okay, now see the third difference. The structures have default designated initializers. Now what are designated initializers? I have discussed all the type of initializers in a separate video. I'll share the link, but let's see the designated initializers here. So here, see, in the case of a struct, if I just write it like this and if I run it, so compile is giving me error that I'm missing argument name and I have to pass it. Okay, so let's pass this as Nilesh. Okay, now that's perfectly fine. I'm just creating object, I'm not doing anything. But if I change it to class, now see, the compiler will give me an error that the employee has no initializer, and when actually you are going to go and fix it, it will assign a default value to name. Okay, and then the error will go away or for this particular classes. So what does this basically mean? That when you want to create a class object, you have to have some value for the name. Okay, so in the case of a structure, what was happening, that behind the scene the compiler was creating something like this for you, and that's the reason that I was able to write the my constructor something like this, that I'm creating employee object and I'm passing name as an argument. But the same thing was not there for the class. So now for the class, I have to exclusively create my designated initializer if I am creating some object with no value at beginning. If I make this variable as optional, then there is no requirement of designated initializers. Okay, so either you make it optional or you provide some default value to it. So that's the another difference, or the third difference between the structures and the classes, that classes don't have designated initializers, structures have designated initializers. Now the fourth difference comes that class supports inheritance and structure don't support inheritance. That means that if I have a class engineer, so engineer can confirm to my employee. So this inheritance is supported in the class, and that's also not multiple inheritance. It's a single inheritance which is supported in the class. But the same thing, if I change it back to the struct, then it will going to give me a error when I write struct engineer which confirms to employee. And you can see that inheritance from the known protocol type employee, that we cannot have inheritance in structures or non-protocol type. Okay, so it's not like that we cannot have inheritance in the structures. We can have it indirectly through the protocols. That means that I can have something like this. I can make this as a protocol. Okay, and I can define this variable as getter and setter. Okay, and then I can confirm to this protocol, and then I can implement this method. So now the compiler will throw me error, it will ask me to implement this particular protocol. So in the struct also you can have the inheritance but through the protocol. Okay, now these are some basic difference between the structure and the classes. Now there is one more difference, that structures are No, we say the struct are faster than the classes. Why? Because structs are stored in the um stack, and classes are stored in the heap memory. And stack memory is faster to no like do any operation. Let's say that if you want to access any variable, it is very easy to access it in the stack memory, but in the heap memory it is little slower, and that's the reason that struct is faster than the class. When you should go with the struct and when you should go with the class, because if we answers in a way like okay, wherever we have to use inheritance, I'll go with the classes. So the moment you answer this, the interviewer will ask you that we can have inheritance through protocols. So I can achieve that, and even I can achieve it in a better way. I can have multiple protocol, like I can have some multiple inheritance features using protocols. So the main answer for this, that if you see a Swift is basically of no, it more relies on value type, and structs are value type, and it is faster in terms of the classes, and that's the reason that when you create your model and all those things, we prefer using struct. Now how it is faster, I'll show you with a very good example. Yeah, so let's see this example. This I have just taken it from GitHub, and this will give you a very clear idea that why you should prefer struct over the classes. Now here if you see that there are this class int class, which is a class and it have one value, and then we are just initializing the value. Similarly, we have the same thing in the struct, we are initializing the value. Okay, and then we have another class which have 10 parameters actually, and the same thing, initializing the value, and then a struct with 10 parameter, and then again initializing the value. Okay, then here if you see, this is a test class, and here we are actually capturing that how much time it takes to initialize a class with one parameter, and then just keep copying the value or keep adding the value into a variable x, which is again a type of value type. Okay, so that means that we are going to see that how much time it takes to initialize the classes, and again the same thing goes that how much time it takes to initialize the struct with one field, and with 10 fields the same structure, the 10 field the same classes, and this is, if you see, it is happening around a million times. Okay, so let's run this and we'll see the time difference. So if you see right now it's running the test, and first it is running the class 1 field. Okay, so see, it took around 6.92 seconds for initializing 1 billion times class with single parameter. And if you see, for the same thing for structures, it took just 4.39 seconds. And the same thing for the class with 10 fill, it was taking around 6.75 seconds. And for the structures, it was taking 4.68 seconds. So there is considerable amount of difference in the time when you are doing some operations on the structures and when you are doing some operation on the classes. And that's why many times you might have read that structures or Swift is faster than the Objective-C. And the reason is that Swift is more on the value type, and value types are stored on the heap, on the stacks, not on the heap, just like how we have the class type. And accessing something on the stack is very faster compared to the heap memory. So that way how you can even answer or that why Swift is faster than Objective-C. Okay, so that's all makes differences between the structure and classes. Now let's move towards the coding questions or some coding challenges that is asked on structures and classes. So this is one of the common questions again which is asked on the classes, and we'll see the same thing with the struct. So if you see here, I have two classes, one is parent and one is child. And if you see, the class is holding a reference of child and child is holding a reference of parent. Okay, and then you will have something like this, that I'm going to create object of first parent and then pass that parent reference to child, and then I'll bind parent child also to the child object. That means both are having a strong reference of each other. Now if I do this parent equals to nil and child equals to nil, now the question will come that whether the deinit method is going to get called or not. Okay, so think in your meanwhile, I'll just run it and see what happens. So if you see that I don't see any output in the console. That means that my deinit method doesn't get called. And the reason for this is that both this parent and child are having a strong reference of each other. Now, before going to give the solution for it, let's try to see the another concept which is called reference count. Now you might have heard that when you create a object, a class object, the reference count increases from 0 to 1, then 1 to some value, and again when you deallocate, the reference count becomes 0. So in this case, if the object is not getting deallocated, that means the reference count is not becoming 0. Now let's try to read out the reference count of this thing. Okay, so if you see in this case, what is the reference count of parent? So you created a parent object, that means parent reference count is how much? It's 1. Okay, and child doesn't exist, so I'll say child 0 because there is no child object at this particular line. Now if the same things come to the next line, now if you see, you are referencing parent to the child. That means it's not like only when you create an object the reference count increases. How many times the object will be referenced, then also the reference count is going to increase. So now the parent becomes 2 and child becomes 1 because now you are creating a child reference. And what will happen in this case? Now you are again using this child to the parent. So now the child will become 2 and parent is also 2. Now when you are making this parent equals to nil, child equals to nil, what is basically happening? We are making the reference, we are releasing the reference. But what was the reference of this child and 2 by this moment 2 2? That means it was not becoming here 0 and 0. It was remaining 1 and 1 because both are having a strong reference of each other. Okay, so one way to solve it like to make any of this references as weak, because you have like parent and then you have child, and what is happening that both are having a strong reference of each other and it is creating a retain cycle, and that's what you should avoid it. So one solution, the easy solution will be that make anyone as weak, and this time when you run it, you will see that it's printing parents tneat called and then child's tneat called. Okay, many times I might be asked that what if I make both as weak? Doesn't matter if you are making one time week, you are breaking that retain cycle. So one week is more than enough. You don't need to make both the references as week. Okay, now let's see the same case. Can I try the same example with the structure? Okay, so let's do the thing. I'm just going to comment this first and I'm just going to change this to structure, and you will see that okay, we don't have dneat method, so I'm just deleting the dneat method. So I don't want any extra error. I just want to see whether it works or not. Okay, so you will see that it's giving you some error. Now what's the error? That okay, first of all, that weak may only be applied to class and class bound protocol types, not parent. Okay, so we cannot have a weak reference inside a structure. That means that if let's say that if I have a struct a and let's try to create weak where num colon int. Okay, this is different from what I was doing here, and let's see that compiler gives you error or not. So see, it's not allowing you to use the weak, because when you are talking about a strong reference, when we are talking about a retain cycle, this all are related with the class bond properties, not with struct bond property. So you cannot have a weak property inside a structures, because structures will never create a retain cycle for you. Okay, so let me delete this and come back to the error that we were getting here. Now if you see that value type parent cannot have a store property that recursively contain it. Okay, now why we are getting this error? The same thing it was allowing for classes, but it was not allowing for the structure, because the value types are basically a fixed structures. Okay, and they occupy a fixed space in the memory. So when you create the object, it creates a memory space into your stack depending on the size. Okay, so we can say that it's kind of that the compiler determines a space. It's like a predetermined space, and basically it happens at the compile time. Okay, so when it happens at the compile time, the compiler needs to know that how much space actually it has to reserve or it has to preserve for a struct. Okay, but how could that space be calculated if the value could contain another value of the same type? In this case, if you see that this value is containing another value of the same type, and then might be this can go on and on and on like that. No, we can have parent child, and then inside child we can have let's say grandchild child, we can have multiple relationship. So in that case what will happen that it will create something a recursion kind of thing, and the compiler will get confused that how much space ideally it has to allocate when it has to create a parent object. Okay, and because everything it has to done at the compile time, not like the class where the things are happening at the runtime. And that's the reason that compiler is not allowing you to have property like this. Okay, so you cannot have, and that's the reason that we are getting error here. Okay, so that's all for today's video. Hope you like this video, and if you really like this video, please do subscribe the channel and don't forget to leave your feedback in the comment section. Thank you.